Okay, so the second part of 11.4, we're still talking about inscribed angles, but we're going to see how that relates with triangles. So this theorem says an inscribed angle subtends a semicircle. So it cuts off and intercepts an arc that's a semicircle if and only if that angle is a right angle. So that means if and only if, remember that's a biconditional statement. That means it works both ways. So that means if you know that this is a right angle, I know it doesn't look like it in my picture, clearly. If this is a right angle, then that means, let's say this is AB, then that means that AB is the diameter of the circle. Because if you think about it, okay, it subtends this arc, and this arc is a semicircle. Oh, well, if this is 90 degrees, what's 2 times 90 degrees? Well, that's 180 degrees. So it works this way, and it works the reverse way. So if you know that AB is a diameter, okay, so here's the center, here's AB, then that means that if you connect, if AB meet at any other point, same point on the circle, that point has to be a right angle. Okay, so that's what this theorem says, and we're going to use it to help us solve problems like this. So here we know that this is the center. That's what this point means, is the center of circle X. So this is a diameter. Since this is a diameter, that means that this has to be a right angle. So all you're going to say is 5a plus 20 equals 90 and solve. So subtract 20 from both sides. 5a equals 70. Divide by 5. A equals, let's see if you do 14. Boom, A equals 14. How can you check your work? Plug it back in. Okay, so here's some harder looking problems. Find measure of angle LJM. 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 So we want to figure out this one. Oh, this is the other one that we were talking about. Okay, so this one, do we have a diameter? Nope. Do we have any right angles? Nope. So what do they want us to do with this one? Well, if you look at these two inscribed angles and look at the arc that they intercept, they both intercept arc LM. So since they both intersect this arc, that means that they must be congruent. So you're going to say that 5b minus 7 equals 3b and solve from there. So subtract 3b, add a 7, and you get 2b equals 7 and b equals 3.5, and you're going to go back and plug it into LJM. And since they are congruent, it doesn't matter if you plug it into this one or this one. Okay, so the next ones you're going to do this problem and title it number 3. You might think of this as being a right angle. You're also going to do this one and title it number 4. And you're probably going to have to look at the fact that they both subtend angle D and angle G, both intercept the same arc. So they have to be congruent. So that's number 3 and number 4. Let's see, those are side 17. Okay, the next thing we're going to do is talk about quadrilaterals. If a quadrilateral is inscribed in a circle, so that means if it's inside a circle, then its opposite angles are supplementary. So what we're used to for parallelograms, what are we used to being true about their opposite angles? Well, we're used to knowing that the opposite angles are congruent. This is not a parallelogram. This is just simply a quadrilateral, and it says that if it's within a circle, then B and D are going to add up to be 180 degrees, and A and C are going to add up to be 180 degrees because they're opposite of each other. They're not right next to you, they're not adjacent, they're opposite. Okay? Alrighty. So, and let's think about why this is, because we're in an honors class, so you're not just going to accept, what I say without thinking about it. So let's think about why this is. If we look at this circle, let's look at what arc, what inscribed angle AB intercepts. So it intercepts all of this circle. And let's just say that this whole circle it kind of looks like 270 degrees to me. I could be wrong, but that's what it looks like to me. So this whole arc BD, arc BCD, major arc BCD, I'm going to say that that's 270 degrees. So if that's 270 degrees, then that means that angle A has to be half of it because it's an inscribed angle. So let's see, that would be 135 degrees. Okay, now if we think about the opposite angle, angle C, what arc does it intercept? It intercepts the rest of it. It intercepts arc BAD. Okay, now this was the arc that angle A inscribed. And this was the arc that angle C inscribed. And if you add it all up, what does it make? It makes a whole circle. So that means it's 360 degrees. So if this black part is 270 degrees, that means that this red part has to add up to be 360. So that's going to be 90 degrees. It has to be because it adds up to be a whole circle. When you add these two up, it equals 360 degrees every single time. So if this whole arc is 90 degrees, what does this angle have to be? That means angle C has to be 45 degrees. It has to be half of 90 degrees. And if you add those two up, they have to equal 180 degrees. So that's how we know that if a quadrilateral is within a circle, opposite angles are going to be supplementary. They're going to add up to be 180 degrees. So let's see how we can use that. Okay. So this is the last one I'll do for you guys. So it says find the angle measures of GHJK. So we want to find all angles. So there's going to be 4 answers for this one. Well, we know that this angle and this angle are opposite, so they have to add up to be 180 degrees, but we don't know anything about angle H. So let's use the other set of opposite degrees. We are not saying they're congruent, they're supplementary. Opposite angles are supplementary. So that means it's going to be 6b plus 20 plus 3b plus 25 is going to equal 180 degrees. So combine like terms, and we get 9b plus 45 equals 180. Subtract, and we get 9b equals 135. Divide by 9, and we get b equals 15. And we're not done. Now that we have b equals 15 degrees, this is our first step. Second thing we need to do is plug it into all the angles. So for angle K, we plug b equals 15 in here, and we get 150 minus 69 gets 81 degrees. Let's see, if we plug it into angle G, we're going to get 3 times 15 is 45. I don't know what I'm doing right there. Plus 25 is 60 degrees. And we don't even have to really plug it into angle J. Angle J and angle G are supplementary. So if this one's 60, I did that right? No, I didn't do that. Plus 25, I think it's going to be 70. Yeah, this should be 70, sorry, not 60. Okay, so angle G is 70 degrees. We know that these two have to be supplementary. So if this is 70, that means angle J has to be 110 degrees. And same thing with angle K and angle H. They have to be supplementary. So if this is 180, then this one has to be 99 degrees, right? 81 plus 99, 80, sweet. So that's how you do this one. This is the last question you're going to do. You're going to title it number 9 on your, number 5, excuse me, on your notes. And I know there's a fraction, that's okay. This is the last question you're going to do on your notes, and you learned 4 wonderful things in these notes. We talked about inscribed angles, we talked about quadrilaterals, we talked about rectangles, and we talked about intercepted arcs. Good luck.